The birth of Earth, before the dinosaurs.
Imagine the universe before our world began. Silence. A void of unimaginable vastness, filled only with the cold light of distant stars. Yet within this emptiness, a story was about to unfold. A story billions of years in the making. A story that would eventually lead to us. At the heart of our story lies a star. Not just any star, but our very own sun. Young and volatile, it blazed with a fiery intensity, casting its light across the swirling chaos that surrounded it. This chaos, a maelstrom of dust and gas, held the building blocks of planets, moons, and all that we know. Pulled together by an invisible force, gravity, these particles began to clump together. Slowly at first, then with increasing speed they collided, creating friction, generating heat. Over eons, this cosmic dance transformed the scattered dust into something more substantial, something magnificent. This was the birth of our world. A planet still unnamed, still taking shape, but destined for greatness. This is the story of Earth, before the dinosaurs, before life as we know it. This is the story of our planet's fiery and dramatic beginning. The early Earth was a place of unimaginable violence. A molten world, its surface a churning sea of magma, constantly bombarded by asteroids and comets left over from the solar system's formation. Each impact sent shockwaves across the planet, reshaping the land and adding to the inferno. Volcanoes erupted with a fury unknown today, spewing lava high into the sky, while rivers of molten rock flowed across the surface, carving out valleys and plains. The air, thick with noxious gases, offered no refuge from the heat. There was no water, no land, only fire. This was a time of immense heat and pressure, a crucible in which the very elements were being forged. Deep within the Earth's core, heavier elements like iron and nickel sank towards the center, while lighter elements rose to the surface. This process, lasting millions of years, shaped the very structure of our planet. Yet, amidst this chaos, order was beginning to emerge. As the Earth cooled, a thin crust began to form on the surface of the molten sea. This fragile skin, constantly broken and reformed by the ongoing bombardment, was the first hint of solidity in a world consumed by fire. It was a small step, but a significant one, on the long road to a habitable planet. Imagine a world devoid of color, shrouded in a perpetual twilight. The sun, a distant muted orb, barely penetrates the thick atmosphere choked with volcanic gases. This was Earth in its infancy, a planet consumed by fire, its surface a roiling ocean of molten rock. Volcanoes, vast and violent, dominated the landscape, spewing forth rivers of lava that flowed like liquid fire across the nascent crust. These were not the volcanoes we know today, with their majestic cones and predictable eruptions. These were fissures in the Earth's very skin, miles long, belching forth unimaginable quantities of molten rock, ash, and gas. The air, thick with sulfurous fumes and the metallic tang of vaporized rock, would have been unbreathable, a searing, toxic miasma. And yet, this hellish landscape was not devoid of a stark beauty. Imagine standing on a precipice overlooking this fiery expanse, the ground beneath your feet vibrating with the fury of the Earth's molten heart. The sky, a canvas of fiery orange and smoky gray, reflects the inferno below, punctuated by the incandescent streaks of meteors blazing through the atmosphere. This was not a world for the faint of heart. It was a world of constant upheaval, where the very ground beneath you could shift and change without warning, consumed by the relentless advance of a lava flow, or swallowed by a newly opened chasm. It was a world of fire, and it would be eons before it could even begin to resemble the planet we know today. The violence of this early Earth was not confined to its fiery surface. The young solar system was a chaotic place, littered with the debris of creation. Asteroids, ranging in size from pebbles to small planets, careened through space, their paths intersecting with the gravitational pull of the nascent Earth. These impacts, each one a cataclysmic event, were instrumental in shaping the Earth we know today. Imagine a massive asteroid, a chunk of rock and metal miles across, hurtling towards the Earth at unimaginable speed. The impact sends shockwaves through the planet, vaporizing rock and creating massive craters hundreds of miles wide. These collisions, though destructive, played a crucial role in delivering water and other essential elements to the young Earth. Locked within the hearts of these cosmic wanderers were the very ingredients necessary for life itself. Water, trapped as ice within the asteroid, vaporized on impact, only to later condense and fall as rain on the cooling planet. And so the dance of destruction continued, a ballet of fire and impact that, over millions of years, shaped the Earth's size, composition, and ultimately, its destiny. Each collision, though catastrophic in the short term, contributed to the gradual cooling of the planet, paving the way for a more stable and hospitable environment to emerge. As the early solar system began to stabilize, the frequency of these cataclysmic impacts gradually decreased. The rain of asteroids, though still a threat, became less frequent, allowing the young Earth a chance to breathe. The relentless bombardment had done its work, delivering water and other vital elements, shaping the planet's surface and influencing its future. With fewer impacts, the Earth's surface, constantly bombarded by the heat radiating from its molten core, began to cool ever so slowly. The endless oceans of magma, exposed to the vacuum of space, radiated their heat away, and the process of solidification began. Like a cooling vat of molten metal, a thin, brittle crust began to form on the surface of the molten sea. This first crust was a fragile, ephemeral thing, constantly broken and reformed by the churning magma beneath and the occasional impact from above. Yet, its very existence marked a turning point in Earth's history, the first tentative step towards a more familiar world. As the crust solidified and thickened, it trapped the heat from the Earth's interior, creating a vast superheated oven beneath the surface. This trapped heat would continue to drive geological processes for billions of years, shaping continents, creating mountains, and providing the energy for life itself. The reign of fire was beginning to wane, giving way to a new era of change and transformation. The stage was being set for the next act in Earth's dramatic story, the arrival of the moon. The early solar system was a chaotic, crowded place. Planets, still young and finding their orbital paths, played a deadly game of cosmic billiards. Earth, still cooling from its fiery birth, was not immune to this cosmic chaos. Then, a cataclysmic event occurred, an event that would shape our planet and our destiny forever. A rogue planet, Theia, roughly the size of Mars, drifted too close to Earth. Its gravitational pull, irresistible and deadly, drew the two planets together in a slow, agonizing dance of destruction. As the distance between them closed, the pull of gravity intensified, distorting both planets, drawing them inexorably closer. The impact when it came was unimaginable. It was not a glancing blow, but a full-on collision, a meeting of worlds that shook the very foundations of the solar system. The energy released by this impact dwarfed anything humanity has ever experienced. Theia, pulverized by the impact, became one with Earth, adding its mass to our planet. In the aftermath, Earth spun wildly, its axis tilted, its surface a molten wasteland. Debris, blasted into space by the force of the impact, formed a ring around the wounded Earth. From this ring of fire and destruction, a new world would be born, a world that would become our constant companion, our protector, our celestial guardian, the moon. Imagine the scene billions of years ago, the Earth still reeling from the impact, its sky ablaze with the fiery remnants of Theia. The ring of debris, a chaotic whirlwind of molten rock and vaporized metal, orbited the wounded planet. Yet, within this chaos, a beautiful transformation was already underway. Gravity, the architect of the cosmos, began to work its magic on the scattered debris. Particles, drawn together by their mutual attraction, began to clump together. As these clumps grew larger, their gravity intensified, pulling in more and more material. Slowly, out of the chaos, a sphere began to form. Within this sphere, the forces of heat and pressure worked tirelessly, melting rock, separating elements, and forging the very core of this new world. The heavier elements, iron and nickel, sank towards the center, while lighter elements rose to the surface. This process, mirrored on a smaller scale from Earth's own formation, gave birth to a new celestial body. Over eons, the fiery glow of the newborn moon subsided. Its surface, once a sea of magma, cooled and solidified, forming the familiar landscape of craters, mountains, and plains we see today. The moon, born from the ashes of a cosmic collision, took its place in the sky, a silent testament to the power of creation and destruction that shapes our universe. The arrival of the moon had a profound impact on the young Earth. Its gravitational pull, though weaker than the sun's, exerted a powerful influence on our planet's rotation and the ebb and flow of its oceans. The Earth, no longer spinning erratically from the impact, began to stabilize, its axis tilted at an angle that would give rise to the seasons we know today. The moon's gravity tugged at the Earth's oceans, creating tides that rose and fell in a rhythmic dance. These tides, far more dramatic than those we experience today, played a crucial role in shaping the early coastlines, eroding rock, and depositing sediments that would one day become the building blocks of life. But perhaps the most significant impact of the moon was its role in stabilizing Earth's climate. The moon's presence acted as a gravitational anchor, preventing Earth from wobbling too drastically on its axis. This stability, in turn, helped regulate Earth's temperature, creating a more hospitable environment for life to emerge. The moon, born from chaos, became an agent of order, a celestial guardian that would watch over the Earth as it took its first tentative steps towards life. The stage was set, the actors in place. Now, the drama of life on Earth could begin. As the Earth cooled and solidified, a new threat emerged from within, a suffocating blanket of volcanic gases. These gases, trapped beneath the newly formed crust, were a potent mix of carbon dioxide, methane, ammonia, and other noxious fumes. This was Earth's first atmosphere, a far cry from the life-giving air we breathe today. Imagine a sky painted in sickly shades of yellow and orange, the air thick and heavy with the smell of sulfur. This toxic atmosphere would have been lethal to any life form we know today. Lightning, crackling across the sky, ignited fires that raged unchecked across the barren landscape. Volcanoes, still numerous and active, continued to pump out gases, adding to the toxic stew that enveloped the planet. These eruptions, though less frequent than in Earth's earliest days, were still powerful enough to reshape the landscape, spewing lava flows that carved new valleys and mountains. Yet, within this poisonous shroud, the seeds of change were being sown. The very gases that made the atmosphere so deadly would, over time, become the building blocks of life. Carbon dioxide, dissolved in the newly formed oceans, would provide the raw material for photosynthesis. Nitrogen, another abundant gas, would become an essential component of proteins and DNA. The stage was set for a remarkable transformation, driven by the power of life itself. The early atmosphere, though toxic to most life forms we know today, was not static. It was a dynamic system, constantly evolving under the influence of sunlight, volcanic activity, and the first stirrings of life itself. These early changes would pave the way for a more hospitable environment, one where life could truly flourish. One of the most significant changes was the gradual removal of carbon dioxide from the atmosphere. As rain fell, it absorbed carbon dioxide from the air, forming carbonic acid. This weak acid reacted with rocks on the Earth's surface, dissolving them in a process known as weathering. The dissolved minerals were then carried by rivers to the oceans, where they were deposited as sediments. Over millions of years, this process, known as the carbonate-silicate cycle, locked away vast quantities of carbon dioxide in the Earth's crust, gradually reducing its concentration in the atmosphere. This process, still active today, plays a crucial role in regulating Earth's climate, preventing runaway greenhouse effects. As carbon dioxide levels fell, the atmosphere's composition shifted. Nitrogen, a relatively inert gas, became more abundant. Methane, broken down by sunlight in the upper atmosphere, gradually decreased in concentration. These changes, though subtle, were creating an atmosphere more conducive to the evolution of life. The stage was set for the next act in Earth's story, the arrival of the oceans. As the Earth continued to cool, a dramatic transformation began to reshape its surface. The once fiery skies, choked with volcanic gases, gradually gave way to a cooler, clearer atmosphere. The rain began. Not a gentle rain, but a torrential downpour, a deluge unlike anything the Earth has seen since. For thousands of years, it rained without respite, a relentless torrent that carved canyons, sculpted mountains, and filled the first oceans. Imagine a world where the sun, a pale disk behind the thick clouds, barely reached the surface. The air, heavy with moisture, crackled with the constant roar of thunder and the flash of lightning. Rivers, swollen to unimaginable sizes, raged across the land, carrying the eroded remnants of the volcanic landscape towards the lowest points, the newly forming ocean basins. As the water collected, it formed vast, shallow seas, their depths still shrouded in darkness. These primordial oceans, rich in dissolved minerals from the volcanic rock, were far saltier than the oceans of today. Yet, within these seemingly inhospitable waters, the miracle of life was about to unfold. The relentless rain, though destructive, was essential for the birth of life as we know it. It washed away the toxic chemicals from the atmosphere, creating a more hospitable environment. It dissolved minerals from the rocks, carrying them to the oceans, providing the essential nutrients for the first life forms. The stage was set, the primordial soup was prepared, and the actors, the first single-celled organisms, were waiting in the wings. Deep beneath the early oceans, life began around hydrothermal vents. Single-celled archaebacteria, thriving on heat and chemicals, pioneered existence in a hostile world. In the dark, pressurized depths, hydrothermal vents became oases where the first life forms evolved, harnessing Earth's energy and setting the stage for evolution. Archaebacteria, ancient single-celled survivors, thrived in extreme environments, using chemical energy to transform a barren planet into a cradle for all future life. From deep-sea vents, microorganisms silently spread through the oceans, adapting, evolving, and laying the groundwork for life's unstoppable expansion. In shallow waters, cyanobacteria emerged, harnessing sunlight through photosynthesis and releasing oxygen, triggering a planetary transformation. Oxygen from cyanobacteria reacted with oceanic iron, forming banded iron formations and, as iron depleted, began accumulating in the atmosphere, ushering in the Great Oxidation Event. The Great Rusting painted the oceans red with iron oxide, marking a turning point as oxygen reshaped the environment and opened new evolutionary paths. Rising oxygen cleared the skies, formed a protective ozone layer, and enabled life to grow larger and more complex, setting the stage for a biological explosion. A symbiotic merger between ancient cells gave rise to eukaryotes, complex cells with nuclei and organelles, unlocking the potential for multicellular life. Eukaryotic cells, through complexity and sexual reproduction, sparked an explosion of diversity, sowing the seeds for all complex life to come. For billions of years, life on Earth had been a microscopic drama, played out on a grand stage of oceans and continents. Single-celled actors, from the hardy archaebacteria to the oxygen-producing cyanobacteria and the complex eukaryotes, had taken their turns, shaping the planet and its atmosphere in ways both subtle and profound. Yet, to an outside observer, the Earth might have seemed quiet, a world of vast oceans, barren continents, and a sky just beginning to clear from the haze of its volcanic past. But this apparent tranquility was deceptive. Beneath the surface, unseen forces were at work, setting the stage for a new act, a dramatic escalation in the story of life. Deep within the Earth's mantle, tectonic plates shifted, continents drifted, and volcanoes rumbled, reminders of the planet's restless heart. These geological upheavals, while destructive, also created opportunities, driving the evolution of new life forms and shaping the environments they would inhabit. The oceans, vast and deep, held secrets yet to be revealed. New forms of life, more complex, more diverse, were evolving in the depths, awaiting their moment to take center stage. The seeds of complexity, sown by the emergence of eukaryotic cells, were about to sprout, giving rise to a riot of forms, from the simplest sponges to the most intelligent cephalopods. The Earth, though seemingly calm, was poised on the brink of a biological revolution. The age of microbes was drawing to a close, and a new era, the age of multicellular life, was about to dawn. The giants were coming, and the Earth would never be the same.